hemihydrate. Hemi means half. Since this contains half molecules of water, that's why it is called hemihydrate. Its overall name is calcium sulfate hemihydrate. Now, preparation of this. Plaster of sulfate can be prepared by the help of gypsum. Gypsum is CaSO4 dot 2H2O. By the carefully heating of gypsum, we can obtain plaster of Paris. Now, when gypsum heated approximately 120 degree centigrade temperature, then it will become converted into calcium sulfate hemihydrate, that is plaster of Paris. Now, here we will discuss some effect of temperature on the gypsum, that is calcium sulfate. Heating effect. In gypsum, that is CaSO4 dot 2H2O. Heated, then first it will be converted into CaSO4 dot 2H2O. The molecular formula is same of both of the structure. This one structure, that is after heating CaSO4 dot 2H2O at room temperature, it is called monoclinic. And after heating, the structure is obtained of the gypsum is called orthorhombic. These two structures, that is monoclinic and orthorhombic, are of similar chemical formula, molecular formula, but have different physical properties. Means monoclinic and orthorhombic are the allotropes to each other. Now, further heating up to 120 degrees centigrade. Orthorhombic form of gypsum converted into plaster of Paris, that is 2CSO4 dot H2O. Here is the two molecule of calcium sulfate contain one water molecule and one water molecule contain half water molecule. Now further heating of plaster of Paris upon 200 degrees centigrade, it will becomes anhydrous calcium sulfate, that is CaSO4. It is also called dead burnt plaster. Dead burnt plaster. It can't have the water absorption property. Now strongly heated of the calcium sulfate gives lime, that is calcium oxide plus SO2 gas plus O2 gas. Now we will discuss the properties of plaster of Paris. The first property of the plaster of Paris is is a white powder. Second one, it has the property of setting to a hard mass when a paste with water is allowed to stand aside for some time. Slight expansion occurs during the setting as water is absorbed to reform CSO4.2H2. The setting process is exothermic. The process of setting takes place in two steps. In the first stage, there is conversion of plaster of Paris into orthorhombic form of gypsum, that is called setting step. 2CSO4 dot H2O, that is plaster of Paris. Setting in the first step and gives a orthorhombic form, that is CaSO4.2H2O. It is the first step of setting. Now in the second state of setting, orthorhombic form changes into monoclinic form, that is called hardening step. This one is called setting step. A step is called setting step and B step is called hardening step. In the hardening step, orthorhombic form, that is this form, converted into monoclinic form. So in the second step, that is in the hardening step, CaSO4.2H2O, that is orthorhombic form, CaSO4.2H2O, that is monoclinic. The setting of plaster of Paris may be catalyzed by sodium chloride, or it is retarded by borax or alum. Addition of alum to plaster of Paris makes the setting very hard. The mixture known as knee cement. Now next important property is, third one is, if plaster of Paris heated at 200 degrees centigrade, it forms anhydrous calcium sulfate, which is known as dead plaster. It has no setting property as it takes the water only very CSO4 dot half H2O. When heated about 200 degrees centigrade, it will be converted into dead burnt plaster, that is CSO4. It is also called dead burnt plaster. Now we will discuss some important uses of the plaster of Paris.